So complete the square on this thing. That's really what we've just done in example 3. So the first thing, take a 2 out. That would give me x squared minus 4x plus 1. So I'm halving every term there. And then complete the square on that by halving the 4 to give minus 2. Squaring that would give me a 4. So I want to take away the 4 and then give a plus 1. So that overall will be taking away 3. And then expanding the 2 inside. So that would be 2x minus 2 squared minus 6. Bang, there we go. Now, it's asking in part B to find the minimum value of y. Now, this is what y is. How would I find the minimum value of that? Well, the minimum value of this part is quite easy to find because I'm squaring a term. Whatever term I choose here, if I square it, it would be positive or 0. So if I put here, for example, minus 10, then minus 10 minus 2 is minus 12, and minus 12 squared is 144, which is pretty big. So the smallest term that this square bracket could be is 0. And this would be the case when x is 2. When x is 2, this whole bracket is 0. And then 0 minus 6 would be minus 6. So then the y value would be minus 6. And that would be the smallest y value it could be. So that was part B. For part C, if I sketch this graph, then all I have to do is to look at the term in front of my x squared. Notice that it's positive, so it's going to be happy. It's going to look like this. Forget the eyes, but yeah, you know that it's going to look like that because it's a positive number in front of the x squared. For example, if it was minus 2x squared in front, then it would look like that. But we know it's not that one. It's the happy face, a smiley face. So now if we plot our minimum coordinate, which was at 2 and minus 6, which is here, so that's going to be 2 minus 6. That is the minimum point. That is the smallest point on here. So then I would draw the rest of the happy face coming from that point. That final line there wasn't very good. It should never go directly upwards like that. And what else I can do here is to plot the points where it cuts the axes. So it cuts the y-axis when x is 0. And when x is 0, all of these x terms are 0, leaving 2. Now this isn't a very good graph because this is negative here. So I should correct that. This is in fact going to go through at 2, so more like that. It's much steeper. So this is going to be at 0, 2. And these two values I could find by rearranging my expression here. And that could be done. I'll do that in a different color, I think. In this way. So if I know that y equals all of that expression, what I'm trying to find is when what values of y I would need to put in here to make x, what values of x I need to put in here to make y 0. So if I can make x the subject, then that would help. So firstly, I would move the minus 6 to this side, so I get y plus 6. And then I would divide everything by 2. And then I would square root it. And with the square root comes a plus minus. And then finally I would add the 2. I'll put that in front. And this is the value of x. So that was just a quick bit of rearranging. You could do that in a number of steps. I've just decided to do it in one step because of space. But now if I say that the y value is 0, what would the x values be? Well, this plus minus generates the 2 that I need. So when y is 0, that's going to be on the x-axis. And the first term, 6 over 2 is 3. The first term would be 2 plus the square root of 3. And the second term will be 2 minus the square root of 3. And these are the two intersections here. the x-intercepts. I haven't written this very well. This should be, I shouldn't really put equals there. I should say that this is x2, it's the more positive one, and this is x1. And that is my x1, and that is my x2. So yeah, they are the points of intersection and my minimum point.